Hi there, my name is RustyBot. This is the first in a series that's going to cover every single Protoflux node. But don't worry, each one is super simple on its own, so this shouldn't actually take too long. Now before we jump right into the actions category and take a look at these nodes, we're going to look at some of the basic ones that you might not even think of as separate nodes. We've got call and async call, which are manual input buttons for sending pulse events. We've got pulse displays, which will display those pulse events once they've reached the end of their chain, as well as show you who triggered them and how many there have been. And we've got relays for pulse chains in this case, which are created just by grabbing a wire. You can delete them and the connection will be preserved, and they just take one input and send it to the other end. They're basically just for organization. There are almost as many inputs and display types as there are data types. So I've got a Boolean manual interface here where I have a checkbox that switches between true or false. Each of these has a relay in between them that you can grab to create and again delete to reestablish the connection. The float input can contain a decimal, float 3 has multiple, string is text, we've got color, and we have slot inputs. So some types take object references instead of being able to manually type, in which case I'll simply open this bitbot, grab the slot out of the inspector, and drop that in here, and then we can see the plain text title as well as the reference ID to it. Now, it's important not to confuse a relay with a cast. So a relay has one input and one output, and it takes a data type in and puts that data back out. A cast has one input and one output, takes a data type in, but outputs a different data type. So in this case, I have a float to int cast, where it's taking a float number and flooring it, so removing the decimal, and then outputting it as an integer. And same thing here, I have an integer that I'm casting to a float. This comes up a lot when you're working with references in here. So a raycast, for example, outputs the collider that it hits. And in order to get the slot from that, when I try to connect it to get slot, it creates a cast that converts from an iCollider object to an iComponent. So since this video is about the actions folder, we're going to start with the write node. This node is used for setting a specific value to a specific field. If I have any object with a value field of some kind on it, either the update order, the actual value, or even the slots transforms, I can grab that, pull it out as a source, and hook that into my write as a variable. This arrow indicates what the write is targeting, and if I hit this call, the value updates to whatever I'm specifying here. Rather than a source, we can also grab variable, and in our context menu, create one of 3 different storage types. Data model store stores the value on the data model. What that means is everyone sees the same thing, and it persists after the click. If I pull out a regular store, this is client side. It's not synced. So when I hit call, I have to do something to the circuit to update it, and now it is properly displaying the value. But another user is going to disagree. So instead, when they hit call and they set it to 10, then we update the circuit. That displays for them. And then for me, I still just see 5. And finally, we have a local. Locals only exist during the pulse context. So what that means is while this pulse is running. If I hook this up to the display and hit call, we're not going to see anything. Now, the write is still writing the number 5 to this local. We just can't see it because this pulse executes entirely within a frame. What I can do to visualize that right now is extend this pulse to this write and use the local to write to a data model store or some other data model synced field. And now when I hit call, we get a 5 here because this write puts the 5 into the local, and during that same pulse chain, the 5 is put into a data model store. Next, we're going to look at increment and decrement. So increment is a ++, decrement is a -. Just like with a write, you can grab variable and create any of the types of stores. I'm going to pull out a display on that. And in order to hook up a store to one of these nodes, I can just drop the output into variable, and now they both reference the same thing. I can also set the name of this value field here. I'm just going to call it value. And when I hit increment, it goes up by 1. When I hit decrement, it goes down by 1. Next, we have the write latch, which is the same as the write, except it's got 2 pulse inputs and 2 data inputs. If you hit the top pulse, it'll activate the top number, putting that into the field. Same thing with the bottom pulse, we'll activate the bottom data. Next, we'll look at the indirect nodes. They're all identical to their direct counterparts, with the key difference being the lack of a variable input field. Instead, they have a regular node input. When I try to take a model store or some other kind of field and drag that into the variable, it instead creates this ref to output node, which has the reference arrow on it. Now, if I call this, it still writes normally, but this is useful if you want to have one node write to multiple fields. So in this case, I have ref to output for arbitrary field A, ref to output for arbitrary field B, and my multiplex is currently set to index 0. So this is going to come through. When I hit call, that goes through to the indirect write, and if I set this to true, it activates true on arbitrary field A. If I change the multiplex index to 1 and then call, it now instead writes it to B. Lastly, for the actions category, we have tween. Tween is short for in-betweening, that's an animation term, where it takes one value and moves it towards another. So I have an initial value and I have a target value. And I also have a target field. This is what this node is going to try to animate. I'm just going to use a float value field here. I'm also, for demonstration purposes, going to pull out a source and a display on that so you can see what number we're working with here. Now, if I set the to value to 1 and I hit call, you can see it animates from 0 up to 1. It outputs a pulse when it starts and it outputs a pulse when it finishes. If I instead remove the from value and set the to value to something like 4, it will now, instead of defaulting to 0, default to whatever it already is. So it's going to go from 1 to 4. What you're mostly going to see tweens being used for is animating slots. So I'm going to take this box I set up, grab the position field of it, and drop that into the target. Now, when I hit call, the box animates upwards. I have it set to go 1 meter directly up and animate from 0. The duration is how long it takes to animate in seconds. The curve is the easing function that it's using. So right now it's smooth, which gives it that sort of in-out acceleration. If I set this to linear, it just moves at a constant speed. And there are a couple other animation style ones that you can play with. I really like bounce out for falling up. Set this back to linear. And we also have proportional duration. So when you turn on proportional duration, rather than the duration input being a time in seconds, it's a multiplier for the speed. So at the moment, it's still going to go up in 1 second. But if I set this to 0.5, it's going to go up in half a second, as expected. Now, if I set the upwards movement to 4, so that is we're moving 4 meters up, rather than taking the expected half a second, it actually takes 2 seconds. That's because with proportional duration, this isn't telling the node, hey, animate within half a second. It's saying move at 1 unit per second with this as a multiplier. So 4 units, 1 unit per second, should take 4 seconds. With a multiplier of half, takes 2 seconds. And that's the actions category. You now know how to operate all of this.